welcome to another episode with McForce. Today I'll be showing you something I've been working on for a while. Um, Basically, in a nutshell, I'll be showing you how we are going to make use of some Salesforce automation and AI to make sense of error log records, more specifically RFlib log records. Now, to set the scene, um, as you would know, you know, errors can cause absolute havoc for a company. They can cause an absolute standstill, war room sessions that can last hours, just them trying to figure out what the problem is. What is the root cause? And how do we actually solve this? So what I am trying to do, I'm trying to make use of AI to actually analyze the log records. Making use of I'm making use of just some simple automation to correlate the records together, creating a hierarchy. I'm also going to ingest the records into Databricks. I'm also going to send then the data into Data Cloud, making use of the zero copy connector. And then um, I'm going to make use of AI to do a root cause analysis and also check for any patterns. So as I explained, from Salesforce, Databricks, Data Cloud, and then basically back into Salesforce to making use of Agentforce. Now the question probably is going to be, why not send the records directly into Data Cloud? Not why are we sending them to Databricks and then Data Cloud? Well, for various reasons. Number one, there could be external logs as well. Maybe, for authentication purposes, they could be making use of a ping, AWS. So maybe they want to send those logs into Databricks as well. Then you can really correlate them together and send them into Data Cloud and really have a full picture as to now determine the root cause. And the greatest thing is the Databricks zero copy connector. So why does this matter? Data Cloud creates a federated virtual reference to Databricks Delta table. What does this mean? The data stays in Databricks, no ETL, no sync jobs, no storage costs, and AI reads directly from Data Cloud. So obviously you want to do some further analysis in Salesforce, and you want to maybe check for, pattern recognition. All right. So let's jump into our demo. Okay, so the process obviously starts with the error log records that being created. So obviously in this process, I'll be simulating that. To set the scene, we've got an external user that's navigating through the Experience Cloud site. He's navigating through, he's clicking on a couple of buttons, he's clicking on pages, and then boom, a whole lot of error messages. Now, as you can see, I mean, it's not the most, I mean, it's only 5 errors, but still, it's quite complex. And then, yeah, so from this to figure out can still take some time. So let's check how quickly we can get AI to analyze these. So I'm going to insert them into our Salesforce instance. Right. Let's see. Refresh. Okay, so I've got 5 new records created. Now, the first thing that's going to happen, I've got an automation that's running in the background that is looking at the platform request ID and basically calling all of them together. And it's looking for the first log. So what is supposed to happen I've created these are the RFlib records. So I created a lookup to itself. So all the child records, basically the first record will be a parent, and then all the child records will be populated on here with that parent record. And the parent record is then set as a parent and the rest child. And there's going to be a sequence. So it will order them as they follow. So basically, which records came in first, second, third. All right. So this can take a minute because in the process or the automation, obviously, it can take some time for all the records to get created. So in my automation, it actually waits a couple of minutes to make sure that all the records are created. So there's a pause, it waits, and then it basically looks for all the records. So I'm just going to pause, and now you'll see what happened is um, first of all, it's defined whether this is a parent or a child, and it's done that by this literally being the first log that's come in. It's sequenced them in the which number it came in, and if it's a child, it related this parent um, to the child records so that this parent would now have a bunch of related ones, and basically that's how it correlated them together. All right. Okay, so what I've done, if we move over to our Databricks instance, I've created the Salesforce logs catalog and a RFlib schema, and I've created this pipeline that I've set up to ingest the RF log records. Super easy to set up, and it's basically scheduled. It runs well, you can set it to whichever, if it's daily, if it's uh, uh, every hour, whatever your use case, whatever is the requirement, right? Um, okay, so this is quickly just computing. And then what I'm going to do while this is going to compute, I'm just going to ask it so that we can see, because this AI is quite cool, how many records are in this table. This probably might take a minute or two just because it needs to finish the computing. Okay, so it's come up with its 1077. So bear in mind the newly created, those new 5 records that I created in Salesforce haven't been ingested yet. Now, as I said, these get ingested like every day, but what I can do is I can actually run the pipeline so that it can ingest it. So if I go into this pipeline, um, I can just start this. Okay, now this does take a minute, and I'll just pause the video again and yeah, unpause when it's basically done. Okay, it's basically almost done. It's literally just still processing, but this shouldn't take long. And then yeah, it's basically running the job to ingest those log records. And there we go. Upserted records 5. Cool. Let's go back and check. So if I go back into my catalog, Salesforce logs, reflib, and sample data. Let's check now. How many records are in this table? Enter and run query. It should be updated to 1082. Here we go. So now that has updated our table. Yeah. So next we will then go into Data Cloud. You will also see the data stream that I've created and set up with the zero copy Databricks connector. And currently, it's also at 1077. This stream is also set up to ingest every, let's see, I think it's also either that I set it up as every 6 hours or every once a day. Oh, it's hourly. Okay, great. So it's every hour. But the cool thing is as well, I can refresh it to ingest the data immediately. Um, this also takes some time. So I'm also just gonna pause the video here. Okay, now we see that it's updated with the 5 records. So it's updated or sent the not sent, ingested the uh, data from Databricks, which is pretty cool. So if we go back to our Salesforce instance, so if I open the parent, I created a couple of extra fields to add in some AI analysis. We've got a summary, we've got an error sequence, we've got the affected components, and it even gives us user actions. So it will tell us uh, the initial action dashboard load triggering the get user subscription. And then subsequent actions at the API marketplace subscription retrieval attempted. And did the user contribute to this? No. User performed expected navigation. It gives us a bit of a root cause code level analysis, and it gives us the overall root cause analysis. The incident involves 2 distinct failure patterns occurring in sequence. Okay, and then recommended actions. It actually goes into the code and it tells us how, like a recommendation on how to fix the code, which is pretty cool. And then this part is where it actually goes and checks in Data Cloud. So RFLib pattern detection historical analysis. The error related to the USB SN user subscription controller component is recurring and indicates a systematic issue. Error frequency, total count 15 times. Frequency recurring. So previous similar error, yes, multiple instances. Pattern type, systematic evidence, multiple logs indicate consistent failures in OSB SN user subscription controller. Right, now this is not too pretty, but what I've done is I've actually created a Lightning Web component because the problem is it's in Markdown. So it's not going to render so nicely. So I've actually created a Lightning Web component um, through a screen flow. So in the screen flow, you call the prompt, and then you've got a Lightning Web component with some CSS to render it better. So if you can see this, this is much prettier. So again, you've got the summary, you've got the error sequence, and as you can see here, this is actually much better. Gives you nice user actions, affected components, um, and the root cause code level, and again, the nice problematic code. Root cause explanation. The get user preference method operates under the assumption that every user possesses at least one subscribed solution record. When the SOQL query returns an empty list, the code attempts to access user prefs, which produces a list index out of bound exception. Boom. There's like basically, I mean, how quick does it tell you in clear words uh, uh, where the problem is formed? And then there's a pattern recognition. I see the columns are a bit wacky here. It's difficult to render it like 100%, but at least it still looks a bit better. And then recommendations, like literally fixing the code for you. So yeah, that is it. My next attempt is actually going to be to go and fix the code. So we are now looking at a self-healing process. That is going to be my next attempt. So yeah, please let me know, what do you think? Would you like to see how I built this? How I set it up? So comment, and yeah, let me know what you think. Thank you.